Uh, Students, now we'll discuss about a typical three-phase system from this of voltage source, but they have two connections, basically two connections. First is three-phase voltage source, Y connected source, and second is delta connected source. It's like a Y, as you can see, and it is a delta, like so. As you know, previous the delta and Y connections, what are delta and what are the Y connections like to be. So in Y connection there is a single neutral, so it is a four-wire system. Three-phase and four-wire systems are typically known as Y connected source. A three-phase system is equivalent to three single phase circuits. There are three single phase circuits, that is VA to N, that is B to N, that is C to N, and three-phase current sources are very scarce. So their current source is quite scarce, but voltage source is available. A three-phase system is equivalent to three single-phase circuits. The voltage sources can be either Y connected as shown 12.6a or a delta connected as in figure 12.6b. In figure delta connected source, here everything is a phase to phase voltage. That is a phase, that is a phase. VAB means face to face A and B. VCA is face to face C and A. VBC is face to face C and B. There is no neutral here, but here can you see there is a neutral. There are single phases to each other, but here all phases are connected to each other. There is no neutral. There is a three-wire three-phase system. So if a mathematics or anything asks you about there are three-phase three-wire system, that means a delta connected source are connected there. If a mathematics says it's a four-wire three-phase system, you can just stop your eye and just keep pushing your just that will be surely a Y connected source. Just keep your eyes shut and keep believing that that will be Y connected source. So there are two connected sources, that is basically we have to know. Here you can see some phasor considerations, that how the balanced phase circuits are considered. Here is a phase drawn here. Each and everything is 120 degree apart, as you can see here. VAN, BN and CN. Let us consider Y connected voltages for now. The voltages VAN, VBN, VCN are respectively between lines A, B and C and a neutral line. There is an A to N, phase to neutral. These voltages are called phase voltages, that is known as phase voltages. The voltages which have line on A to N, that means from a phase to neutral, that will be a phase voltages. If the voltage sources have the same amplitude and frequency omega, as shown here, and are out of phase with each other by 120 degree, the voltages are said to be balanced. If each of the phase voltages are 120 degree apart from each other, if it satisfies it, so it is known as a balanced three-phase circuit. So a balanced phase voltages are equal in magnitude and are out of phase with each other by 120 degree. So it is, if it is VAN is 0 degree, so VBN will be plus 120 degree, VCN will be minus 120 degree, or 120 plus 120 is equal to 240 degree apart from each other. Okay, so we can say it's a balanced three-phase circuit while they are out of phase with each other by 120 degree. If any kind of discrepancies found in the phases, it can't be known as a balanced. So balanced three-phase circuit will be same in magnitude but out of phase in 120 degree apart from each other. So VAN, vectorically we can write it VAN VBN plus VCN is equal to 0 while it is balanced. So each and every phase is equal, that's the magnitude. And since the three-phase voltages are 120 degree out of phase with each other, there are two possible combinations. One possibility is shown in figure 12.7, that is this and other will be this, that is VA BN, that is ABC, and other is ACB. So there are two sequences C. One is ACB combination and other is ABC combination. There are two popular combinations are found here. So two possible combinations we can found here. One is ACB. Here is a sequence A, then C comes, then B comes. ACB combination is C, you can see here, and that is ABC combination as B here. A, B, C combinations. So we can express mathematically as like this, like a VAN, I can see here ABC or positive sequence and ACB or negative sequence. Okay, so two combinations. If it is ABC, that will be positive. If it is ACB, that will be negative sequence. Why? Because B and A are apart from 120 degree and positive plus 120 degree, so it is a positive sequence, and there is minus 120 degree apart from each other, so that will be known as a negative sequence. Now you can say that can be expressed mathematically. VAN will be VP 0 degree. That means the voltage will be same, that is phase voltage, so it is known as VP, it's denoted by VP. VBN will be VP minus 120 degree. VCN will be VP minus 240 degree or VP plus 120 degree. Both are equally right. If it is ABC sequence, you can see here one plus 120 degree. That is ACB sequence, so it's minus 120 degree. That is from the previous combination. Okay, now come to the point of the positive sequence and negative sequence. VP is effective RMS value, and this is known as ABC sequence or positive sequence. In this phase sequence, VAN leads VBN. VAN leads VBN.